In this video, I'd like to talk about the math question of the day for January 30th, 2023. And with this problem, we need to solve for x in this exponential equation. So to solve a problem like this, you need algebra 1 and algebra 2. And at this point, go ahead and pause the video, see if you can solve this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, we can go through this together. And as always, if you have any suggestions for questions of the day, feel free to leave those suggestions in the comments. Now, for exponential equations, there are a couple main strategies to use. But if we just have one exponential term with the variable in the exponent, then the main strategy will be to solve the equation for this exponential term. And from there, we can either use logarithms or we can rewrite each side of the equation with the same base if that's possible. So let's start by solving for this exponential term. We can add 7 on each side of the equation so that we get 2 to the 3 minus 8x is equal to 11 plus 7, which is 18. Now, if this side was a power of 2, like 16, then we can rewrite that as 2 to some power, and then we can recognize that we have 2 to some power is equal to 2 to some power, and those exponents must be equal to each other, and we would be able to then solve for this missing variable. However, in this case, we can't do that since this is not a power of 2. But what we can do is rewrite this as a logarithm and then use the properties of logarithms to solve for x. So the main property of logarithms that we want to use is essentially just converting between exponential form and logarithmic form. So let's say we have a to the b is equal to c. We can rewrite this as a logarithm. We have log base a. The base of the logarithm and the exponential expression are always the same. And logarithms are equal to exponents. So this logarithm will be equal to whatever this exponent is. Logarithms are exponents. And then c would be the input of the logarithm. And we read this as log base a of c is equal to b. And the way to interpret this is when you see this logarithm, we're just asking a raised to what power would give us c. And that power we want to raise a to is b, whatever the logarithm is equal to, because like I mentioned, logarithms are exponents. So let's use this idea here. These are equivalent. We can rewrite this in its logarithm form. We have log base 2. The bases are always the same in the two forms. And the logarithm is equal to the exponent. So this logarithm will be equal to 3 minus 8x. And the input of the logarithm is what the exponential equation is equal to. So we have log base 2 of 18 is equal to 3 minus 8x. And from here we can manipulate this and actually solve for our missing variable x. So let me just make a little bit of room so we can keep working. And to get x by itself, we just need to remember this is a number. We can evaluate that on the calculator. So let's isolate this minus 8x term. We can subtract 3 on each side of the equation so that we get log base 2 of 18 minus 3 is equal to negative 8x. And lastly, we can divide each side of the equation by minus 8 so that we can get x by itself. So we have that x is equal to log base 2 of 18 minus 3. And all of this will be divided by minus 8. At this point, we can use our calculator here, though you may need to use the change of base rule for the logarithm. So if we have a logarithm that doesn't have a base of 10 or e, then you might not have a button for that on your calculator. So if we have log base a of b, we can rewrite this using whatever base we want, log base c of b over log base c of a. This is just the change of base rule for logarithms. And usually we will use base 10 or base e since we typically have a button for that on the calculator. So if we rewrite log base 2 of 18 using, let's say, the common log base 10, we would have log base 10 of 18 over log base 10 of 2. And of course, with the common log, we typically will omit the base. We just assume that it's 10 when we write log. So with log 18 over log 2. Though we could also use base e here, where e is the exponential constant. It is 2.71828 and so on. It's irrational like pi. So we could also write this as the natural log, log base e. I should write that down. The ln of, let's say, d is just log base e of d. So we have that this log base 2 of 18 could also be written as log base e of 18, or the natural log of 18, over the natural log of 2, log base e of 2. And if we evaluate this on the calculator, let me just make a little bit of room here, but we would get an irrational number. So we need to approximate. This would be approximately 4.16992 or 17 we could write. And if we plug that value in here, we will get an approximate answer. So if you want an exact answer, then this is the exact answer. But if you want a decimal answer, then x would be approximately minus 0.14624 and so on. So we can just approximate it as this value here. And at this point, if you want to check your work, we can go back up to the original equation, and the value we have for x, we can plug that in and see if it actually makes sense as an answer. And I will leave that as an exercise to the viewer, but when you do plug it in, you will see that it does make sense.